Imagine a time before time existed. Then suddenly, an explosion of unimaginable power, the Big Bang. This event, about 13.8 billion years ago, marked the beginning of our universe. The Big Bang wasn't like an explosion we know happening in a specific place. It was the expansion of space itself. Imagine a tiny balloon suddenly inflating to an enormous size. That's more like it. As the universe expanded and cooled, energy transformed into particles, eventually forming atoms like hydrogen and helium. These simple elements would become the building blocks of everything we see in the cosmos, including our own solar system. But the journey from the Big Bang to our solar system was long, taking billions of years and involving spectacular cosmic events. Billions of years after the Big Bang, a giant cloud of gas and dust called a nebula drifted through the Milky Way galaxy. This nebula, our solar system's cradle, contained the remnants of long-dead stars, enriched with elements like carbon, oxygen, and iron. Something disturbed this peaceful cloud, perhaps the shockwave from a nearby supernova explosion. This disturbance caused the cloud to collapse under its own gravity. As the cloud shrank, it began to spin faster and faster, like a figure skater pulling their arms in during a spin. This spinning motion flattened the cloud into a swirling disk, much like a spinning pizza dough. At the center of this disk, gravity pulled most of the material inward, creating a dense and hot protostar, the seed of our sun. Deep within the collapsing cloud, the protostar continued to grow hotter and denser, its core a raging inferno of nuclear reactions. The intense pressure and heat at the core became so great that hydrogen atoms began to fuse, releasing tremendous energy. This fusion process, like a giant hydrogen bomb, marked the birth of our sun. The sun blazed to life, flooding the surrounding disk with light and heat. The sun's powerful gravity kept the remaining material in the disk orbiting around it. This material, mostly gas and dust, would eventually form the planets and other objects in our solar system. The birth of the sun was a pivotal moment, setting the stage for the formation of our planetary neighborhood. In the swirling disk around the newborn sun, tiny dust grains, like cosmic dust bunnies, collided and stuck together. This process, called accretion, is like building a snowman. Small pieces gradually combine to form larger ones. Over millions of years, these dust grains grew into pebbles, then boulders, and eventually into planetesimals, small bodies kilometers across. The planetesimals, drawn by gravity, attracted more and more material, growing larger and larger. Near the sun, where temperatures were scorching, only rocky materials like iron and silicates could withstand the heat. These materials formed the inner rocky planets: Mercury, Venus, Earth, and Mars. Section 5. A rain of fire and ice. Farther from the sun, beyond the frost line, temperatures were cold enough for ices like water, methane, and ammonia to remain solid. These ices, along with rock and metal, formed the cores of the giant planets: Jupiter, Saturn, Uranus, and Neptune. The giant planets, with their massive gravity, swept up vast amounts of gas and dust from the surrounding disk. This is why they are much larger than the inner rocky planets. The early solar system was a chaotic place. Planetesimals collided with each other in colossal impacts, shaping the surfaces of planets and moons. Some impacts were so powerful that they tilted planets on their axes, or even created moons from the debris. Section 6. Mercury, a scorched world. Closest to the sun, Mercury is a small, rocky planet with a scorched surface. Imagine a world baked by the sun with temperatures reaching a scorching 430 degrees Celsius or 800 degrees Fahrenheit during the day. Despite its heat, Mercury has ice at its poles, hidden in deep craters that never see sunlight. This ice, perhaps delivered by comets or formed from trapped water molecules, hints at a more dynamic past. Mercury, with its thin atmosphere and cratered surface, offers a glimpse into the early solar system when collisions were common. Section 7. Venus, Earth's twisted sister. Venus, often called Earth's twin, is a world of extremes. It's similar in size and composition to Earth, but shrouded in a thick, toxic atmosphere composed mainly of carbon dioxide. This dense atmosphere traps heat, creating a runaway greenhouse effect that raises surface temperatures to a scorching 462 degrees Celsius or 863 degrees Fahrenheit, hot enough to melt lead. Venus rotates slowly in the opposite direction to most planets, a mystery that puzzles scientists. Its surface, hidden by thick clouds, reveals vast plains, towering volcanoes, and evidence of past volcanic activity. Section 8. Mars, the red planet's secrets. Mars, the red planet, has captivated our imaginations for centuries. Its rusty red color comes from iron oxide, or rust on its surface. Mars was once a warmer, wetter world, with evidence of ancient rivers, lakes, and perhaps even oceans. Today it's a cold, dry desert with a thin atmosphere, but scientists believe that water ice may still exist beneath its surface. Mars is home to the largest volcano in the solar system, Olympus Mons, and a canyon system, Valles Marineris. So grand it dwarfs the Grand Canyon on Earth. Could life have once existed on Mars? Section 9. Our solar system's future. Our solar system, a cosmic ballet of planets, moons, asteroids, and comets, continues to evolve. The Sun, our life-giving star, will eventually exhaust its nuclear fuel, transforming into a red giant star. As the Sun expands, it will engulf the inner planets, including Earth. The outer planets will survive, their icy moons perhaps becoming habitable as the Sun's warmth reaches farther into the solar system. But even in the face of cosmic change, our exploration of the solar system continues. We send robotic emissaries to distant worlds, seeking to unravel the mysteries of our celestial neighborhood and to understand our place in the vast universe.